Hi guys, what's up? Mick the mechanic here. Got a few things going on today. Show you quickly what's going on here. 3D printer, printing some spacers. And these are gonna go on my wing, just a stock wing. I'll just raise it up, give it a bit more angle. So you will see. Should actually be pretty nice when it's done. I hope to achieve a little bit of downforce on the rear with this. I don't know if it's gonna work, but no. Small amount of 3D printing materials. It doesn't cost so much. We'll test it out. But the main reason that I'm making this video today is when I show you about a tool that I'm building, a track day tool. It's actually a mobile air compressor for adjusting tire pressures at the track day. At the moment it's not so nice, we don't have any way to do it when we go there, when there's some race or some track day or something. And then if we let the pressure out of the tires, we have to always travel to a petrol station at the end of the day. It's actually super annoying. So here's what I've got so far. I've got a compressor from BMW Air Suspension. Here, BMW, here's the part number if anyone's interested. It's a pretty powerful machine. It's capable of about 18 bar or so. And then this feeds into two tanks. And these tanks are going to get charged up to 15 bar. So you can connect it to 12 volts with the crocodile clamps to the car battery. Pump it up to 15 bar, take it with you to the start line, to the pits, whatever. And adjust the tire pressures. I've got an air dryer on there because we want clean, dry air going into the tires, so we don't need to worry about expansion. Not quite as good as nitrogen, but yeah, when it's properly dried, it's not too far off. We've got the pressure sensor here. This is a 300 psi pressure transducer. That's about 20 bar. That's also more than enough. And this will be connected to an arduino, and the arduino will take the information from this and turn the relay on and off for the compressor. What I had most of this stuff done for a while. The part I'm working on now is the electronics here. So first of all, we have the Arduino Uno, and this is going to be the main brains for the project. Then this circuit board here that I'm building will come between it, and then the screen, the display will then come on top of this. I'll put a display here that it's already on a shield. It will connect straight on there, and this display fits into the 3D printed housing. And we've got a 3D printed housing. A fuse comes in the top here, some status LEDs, and the power button. So, if we take a closer look at the electronics, I'll explain to you exactly what's going on here. We've got a buck converter, which brings 12 volts or 13 volts, depending if the engine is running, brings it down to 5 volts. 5 volts goes into the lithium battery charger, which produces 4.2 volts constant current to charge the battery. The battery is connected to a step up. Step up brings the voltage back up to 5 volts, gives a nice constant voltage for the pressure transducer and for the Arduino Uno. On the left side here, we've got a P MOSFET, and this is for reverse polarity protection. So if you connect the crocodile clamps the wrong way around, nothing bad is gonna happen. I'll pull up the computer screen now. Okay, here's the schematics. So we'll start off here at 12 volt. You've got some crocodile clamps that will connect to 12 volts. This design is a bit older. I've actually replaced this diode here. This is the reverse polarity protection that would blow the fuse normally if you connected it the wrong way. Instead, I've installed P MOSFET. So 12 volt goes into the buck converter. Buck converter brings it down to 5 volt. 5 volt goes into the lithium charger. It's connected to the lithium battery. I'll explain all of this in a moment. Goes into the boost converter, brings it back up again to 5 volt, and then goes into all of this stuff here. This is a latch circuit. When we're not connected to 12 volts, we press the button, the Arduino powers up, we press this button, it bridges the MOSFET here, powers up the Arduino through the step up. The step up writes this pin high, which switches this transistor, which then switches the MOSFET, and the Arduino will remain powered until the Arduino writes this pin low. The timer is set for about 20 seconds. So when we're not connected, we press a button, the display lights up, shows us how much pressure is in the tanks. After about 20 seconds, switches off automatically. This will save the battery life. Now, if we are connected to 12 volts, the charger is powered through the buck converter, the battery charges, but the Arduino stays off until you press the button. When you press the button, it turns on and stays on because we have a connection to the buck converter here, which switches this transistor, which pulls this pin low. So the Arduino knows we're connected to 12 volt, it doesn't run the automatic shutdown timer. These two diodes are very important. The reason for this is when we're connected to 12 volts, the lithium charger should only be charging the battery, and we shouldn't be pulling current from this because this should provide a constant current to charge the battery. So the first diode lets power from the battery in to the step up when we're not connected to 12 volts. When we are connected to 12 volts, we have a direct connection from the buck converter through here going into the Arduino. So we're not pulling any current from the lithium charger. We get some safe charging current, nice stable current for the battery here. And then these diodes just prevent current feedback, so that we're not pumping current from the buck converter into the battery, which would be bad. And we're not looping the current back around into the charger, which would also be bad. Here we have the diagram, or this part of the schematic, is for the relay. When this pin here goes high, it switches this transistor and connects the relay to ground. On the other side is connected to 12 volts from the battery connection. And then this switches on and off depending on input from the pressure transducer. So we'll switch off at 16 bar, so 15 bar, 16 bar, we'll switch off, and we'll switch on again at 10 bar. So you can leave it connected and then use the compressor, and we'll switch on and off automatically. We have a diode in here. This is just like a flywheel diode, so that you don't get any induction spikes when you switch off the relay, which could damage the Arduino. And then we've also got the display here connected to 3.3 volt output from the Arduino. So that's the schematic. Now we can go to the 3D design. Oh, I just gotta update this here. Oh, I don't know what happened there. Okay. Let's get rid of that. I got version 3 now. So I'll just pop this on and show you guys how this will look. So, oh shit. Let's just get rid of the rear cover for now. Oh, and the fuse. They're not joined, so okay. Nope. Okay, so here we go. This is the design. We've got the output from the compressor, goes into the tanks. I will just remove this cover here so you guys can see it. A lot of stuff going on here. So, compressor output going into the tanks. Transducer connected to the Arduino. Air dryer, got a bracket here for strain relief so that when we're tugging around on this with the hose, it's not just pulling onto the fittings here. All the bolts are aluminium, anodized. These pieces are all 3D printed. Got the air filter, power button. So when you're not connected to 12 volts, you press the button, Arduino turns on, 20 seconds, shows you the pressure, switches off automatically. We got one light here. This shows the condition of the battery. When we are connected to 12 volts, it will tell you if the battery is charged or charging. The other is a status LED for the relay, which will show if the relay is switched on or off, or should be switched on or off. These tanks, they're old oxygen tanks, or not old, but they're used oxygen tanks from a small acetylene torch. They're capable for 165 bar. They're rated for like over 100 bars. So 15 bar, what I'm playing with here, is no problem. And this is just normal push connect hose. This is rated to like 27 bar. Also not a problem. And the compressor, this BMW air suspension, this is rated also for like 20 bar or something. Also not a problem. These pieces, the two-piece, the clamps, so we can make them disappear for a second. Clamp 2, clamp 1, then we've got the tanks. And these two pieces are mounted to the compressor through small rubber connectors. So this is shock mounted. Vibrations not a problem here. Relay is mounted in the back here and will be connected to the Arduino. So yeah, that's the 3D design and the schematics. So guys, super excited to finish this project. It's gonna be way better than one of those cheap compressors that you buy from eBay or something. Yeah, it's gonna be super easy. Connect it to the battery, charge the tanks, take it with you and just pump up the tires, or just even leave it connected to the car battery while you're using it. Everything's automatic, digitized, digital display, press the button. Even if you're not connected to the car battery, it'll still show how much air is in the tanks. And I think it's gonna be a wicked machine. Gonna make life a lot easier on the track days, and really looking forward to getting it finished up. So when I get a little bit further with the project, I'll post an update video. Until then, I will see you again. Mick the Mechanic here. Peace out.